Hi guys, in this video I'm going to run through 6 examples of recurring decimals to fractions proof style exam questions. Now because these are proof questions, with the word prove here, that tells me it's going to be a proof question, I need to make sure that I show all stages of the working, especially as it kind of gives me the answer that I'm looking for. I have to make sure that I show every single step, every single stage of working that leads me from there to there. So, example 1, prove that the recurring decimal 0.4 recurring is equal to 4/9. So I'm going to start off by saying let x equal 0.4 recurring. X is 0.4444 on for an infinite number of decimal places with that recurring number of 4. Now, in this decimal, I have got one number that is recurring, and that's the 4. So what I'm going to do is I'm going to multiply by 10 to give me 4.4444, etc. recurring. All I've done is multiply this number by 10. I'm now going to do the larger one, and I'm going to subtract the smaller one from it. So 10x, which is my 4.444. And I'm going to subtract x, which is 0.444. So I get 4 take away 4 is 0, 4 take away 4 is 0, 4 take away 4 is 0, my decimal point, 4 take away nothing is 4. 10x take away x leaves me with 9x. So 9x is equal to 4. I now have a nice simple equation. I can just divide both sides by 9 here, and get x is equal to 4/9. And that is as simple as these style of questions get. I've shown that x is 0.4 recurring, I've shown that x equals 4/9, and therefore that is the full proof with the full workings. Example 2, express the recurring decimal 0.51 recurring as a fraction, give your answer in its simplest form. So I'm going to start off. Let x equal 0.51 with the 5 and the 1 recurring this time. So x is equal to 0.51, 51, 51 forever. 2 numbers are recurring this time, and therefore I'm going to multiply by 100. So 100x, so 100 times that gets me 100x, and 100 times that is going to get me 51.515151. Just as I did before, I'm going to do the larger one and take the smaller one away from it. So 100x, which is 51.5151, etc. Subtract x, which is 0.5151. It doesn't matter how many decimal places that you write in this part of the calculation, as long as you ensure that you are lining up the decimal places. So you've got your tenths in line, you've got your hundredths in line, you've got your thousandths in line, etc. as you go. You do also need to make sure that they line up when you do your x and your 100x, etc. And that's kind of the purpose of why I've multiplied it by 100 here. And for the previous one, when I only have one number that was recurring, I multiplied it by 10. So now I've got this, I'm going to subtract just as I did. 1 take away 1 is 0, 5 take away 5 is 0, 1 take away 1 is 0, 5 take away 5 is 0, and then 51 take away 0 is 51. 100x minus x leaves me with 99x, so I get 99x is equal to 51. Divide both sides by 99, I get x is equal to 51/99. I have expressed the decimal as a fraction, but I haven't given it in its simplest form yet. I haven't looked to see if there's a number that goes into both 51 and into 99. I know that 3 goes into both. So if I divide 51 by 3, if you're not 100% confident with the answer to that, just do a bus stop. 3 into 5 is 1 with 2 left over. And 3 into 21 goes 7. So your answer is going to be 17 over 99 divided by 3 is going to get me 33. So x is equal to 17 over 33 as a fraction in its simplest form. Example 3. Prove that 0.27 can be written as the fraction 5 over 18. So let x equal 0.27. Now, although I've got 2 digits here, only the 7 is recurring. So I've got x equals 0.2777 on for an infinite number of decimal places. So one number is recurring, so I am going to have 10x. Multiply x by 10 leaves me with 2.7. Go from there. So 10x equals 2.777. X equals 0.277. And I'm subtracting those. 7 take away 7 is 0. 7 take away 7 is 0. 7 take away 2 is 5. And 2 take away 0 is 2. 10x minus x leaves me with 9x. So 9x is equal to 2.5. Divide both sides by 9. I get x is equal to 2.5 over 9. Now this is a problem because I have got a decimal within a fraction and I don't want that. To get rid of the decimal in the fraction, I need to times that by 10. So because I'm going to times my numerator by 10, I must times my denominator by 10, or multiply I should say, sorry. Multiply my numerator and my denominator by 10, and that gets me 25 over 90. I know I need to get to 5 over 18. I need to show, because it's a proof question, I need to show that I understand what I'm doing to get it to the 5 over 18. So I need to do 25 divided by 5 to get to the 5, and then I need to just check, does 90 divide by 5 to get 18? Yes, it does. So that I must show that final step really clearly, that I'm dividing by 5 to get to that final answer that I've been given. Example 4. Prove that the recurring decimal 0.306 recurring is equal to 34 over 111. So let x equal 0.306 recurring. Now you'll notice here I've got 2 numbers that have got the recurring dots above them. What that means is the whole thing here, 3, 0 and 6 are recurring. We just write the recurring dot on the first number in the pattern and the last number. So that tells us it's the first number and the last number in the pattern. So x is going to be 0.306 forever. 3 numbers are recurring this time, the 3, the 0 and the 6. So I'm going to multiply by 1000. So remember, when there's one number that is recurring, I multiply by 10. When there was 2 numbers that were recurring, I multiply by 100. If there are 4 numbers recurring, you'd multiply by 10,000, etc. It just works like that. So going back to this one, I get 1000x, so I'm going to need to multiply by 1000. 306.306, 306, etc. As with all of the others, the larger one minus the smaller one, whoops, 306. 6 take away 6, 0, 0 take away 0, 0, 3 take away 3, 0, 6 take away 6, 0, 0 take away 0, 0, 3 take away 3, 0, decimal point, 306 take away nothing is 306. 1000x minus x leaves me with 999x, which is equal to 306. With my equation, divide both sides by 999. I get x is equal to 306 over 999. I need to simplify this down. Now you can either say, right, what do I know 999 divides by to get me to 111? Or you can say, I know that both of these are going to divide by 3. So 306 divided by 3 is going to be 102. 999 is going to get me 333. Divide that by 3. 102 divided by 3 is going to get me 34 over 111. Again, just do a bus stop. If you're not 100% confident, it doesn't matter. Better to do some form of working and get it right than do no working and not get it. So there we go. X is equal to 34 over 111, and that's what I needed to prove at the beginning of my question. 2 more examples to go. Express the recurring decimal 0.84 recurring as a fraction in its simplest form. So let x equal 0.84 recurring. The 4 is only the number that is recurring, so I have got that there. Because I've got one number that's recurring, I multiply by 10. 10x is equal to 8.444, etc. By now I'm sure you know what I'm going to do. The large one subtract the small one. Four take away 4 is 0, 4 take away 4 is 0, 4 take away 4 is 0. Then watch out here, I'm doing 4 take away 8, not 8 take away 4. So 4 take away 8, I'm going to have to take from the 8 and carry. 14 take away 8 is 6. Put a decimal point in. 7 take away nothing is 7. 10x take away x is 9x. So I get 9x is equal to 7.6. Divide both sides by 9. X is equal to 7.6 over 9. Again, I have a decimal within my fraction, so I need to get rid of that by multiplying by 10. So 7.6 times 10 is 76, 9 times 10 is 90. That is a correct answer. However, to get the full marks, it's asking me for this in its simplest form. So I need to think what goes into both 76 and into 90. I know that they can both be divided by 2. 76 divided by 2 is 38. 90 divided by 2 is 45. Is there a number that goes into both 38 and into 45? No, there's not. So that's your answer, your final answer as a fraction in its simplest form. Final example. Prove that 0.473 with the 7 and 3 recurring can be written as the fraction 469 over 990. So let x equal 0.473 with the 7 and 3 recurring. So x equals 0.4737373. Two numbers are recurring here, so I'm going to multiply by 100. So I get 47.37373. Large one take away the small one. Making sure that you line up your columns. Remember, as we've seen in previous ones, you don't always have the same number, but eventually the further you go down your decimals, they will be the same digit in that column. So you may not always, like the 3 and the 4, those are the tenths for each of those different numbers, and as you go through your decimal places, there should be the same pattern that then recurs in that column. 3 take away 3 is 0, 7 take away 7 is 0, 3 take away 3 is 0, 7 take away 7 is 0, 3 take away 4, not 4 take away 3. I'm going to need to take from here. So I get 13 take away 4, put that decimal point in, I'm going to get 9, and then 46 take away 0 is going to get me 46. 100x minus x is going to get me 99x. So 99x is equal to 46.9. Divide both sides by 99. X is equal to 46.9 over 99. Again, a decimal in a fraction, not a good thing. Times by 10, times by 10. The whole point of timesing by 10 is so that I can get rid of this decimal place. I have to do the same to the numerator as I do to the denominator. So I need to times both by 10. So I get 469 over 990, which is the answer that I was asked for in my question.